हेलो गाइस। आप सबका स्वागत है अपने चैनल पे। आज सीरीज का फर्स्ट पार्ट है। इन दिस वीडियो वी स्टडी अबाउट सेट। सेट बेसिकली होता क्या है? इट इज एन अनऑर्डर्ड कलेक्शन ऑफ ऑब्जेक्ट्स कॉल्ड द एलिमेंट्स और द मेंबर्स ऑफ द सेट. Like there are 12 students and 3 schools A, B, C. Consider 3 students are in a A school, 4 students are in a B school, and last 5 students are in a C school. So we say that 3 students are the elements of the set A school, 4 students are the elements of the set B school, and last 5 students are the elements of the set C school. Now we see how to represent the set. Here we say that in this way we represent a set like A belongs to A means A is the element of a set A. When we see A does not belongs to A denotes that A is not the element of A. So sets are denoted by uppercase letters also called as capital letters, and the elements of the sets are denoted by lowercase letter also we call small letters. Now we see examples of a set. First example is a set of all positive numbers. Second, a set of all the planets in the solar system like Earth, Mars, and many more. Then third is a set of all the states in India. So there are 29 states in India. So these 29 states are the elements of the set India. And last example is a set of all the lowercase letters of the alphabet. Now we see representation of sets. So there are two ways to represent our sets. First, roster or also we call tabular form, and second is set builder notation form. First we see roster or tabular form. In this form, set is represented by the elements are enclosed by in brackets and separated by the commas. Now we see examples. First example, set of vowels in a English alphabet. So A, E, I, O, U are the vowels are enclosed in a brackets and which are separated by the commas according to the roster or tabular form. Another example is set of odd numbers less than 10, which is 1, 3, 5, 7, 9. So here we see that 1, 3, 5, 7, 9 are enclosed in a brackets and separated by the commas according to the our roster or tabular form. Now we see set builder notation form. In a set builder notation form, the set is defined by specifying a property of that element of the set having a common. Means there is a one property which is a common between elements, and this property are specified in the set builder notation form. In this way we represent our set builder notation form. Here x is the member of the set A and px is the property of the set A. It is the diagram for better understand to the set builder notation form. So the set of all x such that x is a greater than 0. So it is a diagram. Now we see examples of a set builder notation form. First is the set 13579. So हमें इसको अब सेट बिल्डर नोटेशन फॉर्म में लिखना है. So हमें अब प्रॉपर्टी फाइंड करनी पड़ेगी. So 13579. So basically it is greater than or equal to 1 and less than or equal to 10. It is the first property. Now we find another property. So there is another also property. It is the odd numbers less than 10. Now we represent these numbers in a variable called as a x, and now we write their property. First here it is x greater than is equal to 1 and smaller than equal to 10. And now we type another property. which is for a odd numbers. So x percent 2 is not equal to 0, means it shows the odd numbers less than 10, which are 1, 3, 5, 7, 9. Now we see second examples. सो हमें इसका भी सेट बिल्डर नोटेशन फॉर्म फाइंड करना है. सो इट इज ऑल द इंग्लिश अल्फाबेट, ऑल्सो इट इज द वोवेल. फर्स्ट हमें इसको रिप्रेजेंट करना है एक वेरिएबल से. सो वी कॉल एज अ वेरिएबल एक्स. अब हमें इसकी प्रॉपर्टी लिखनी है. सो एक्स इज अ वोवेल इन अ इंग्लिश अल्फाबेट. Now we see some important steps. First is a n. So n denotes all natural numbers which are starting from 1, 2, 3, 4. Capital Z contains set of all integers like -3, -2, -1, 1, 2, 3, and 0. Means in a Z means contains all the positive integer, negative integer, and also 0. Now we see Z plus, which contains the set of all positive integer like 1, 2, 3, 4, 5. Now we see Z minus, the set of all negative integer like -3, -2, and -1. Now we see capital Q. So it represents all rational number. And now we see capital R. So when we see capital R, the set of all real numbers, we conclude. In a real numbers, we see that there are all numbers are real number like 2.5, 2 raised to 3 by 4, 1 and half hour. It all are like an example of real numbers. Now we see capital W. So capital W denotes the whole number which are starting from 0, 1, 2, 3, 4, and goes to infinity. Now we see capital C. So capital C denotes the complex number which are represented by A plus Bi in brackets. Now we see Cartesian product. So basically Cartesian product होता क्या है? It is the product between two sets. Like example, there are two sets A and B and their Cartesian product is denoted by A multiply by B. मीन्स जो भी एलिमेंट ए एंड बी में होंगे उनकी मल्टीप्लीकेशन करने की. सो इट इज द फॉर्म ऑफ अ कार्टेशियन प्रोडक्ट. It is the representation of a Cartesian product. Like A is an element of A and B is an element of B. Now we multiply these elements A into B and it is the element for a Cartesian product of A into B. We see one sum for better understanding the Cartesian product. A having elements 1 and 2 and B having elements A, B, C. Now first we see Cartesian product of A and B. So first element of A we do multiply with the all elements of a set B like 1A, 1B and 1C. Now we take second element which is the second. Now we multiply with the set B like 2A, 2B and 2C. Here we see that Cartesian product of A and B. Now we see the Cartesian product of B and A. So again same procedure. We multiply first element of B with all elements of set A like A1, A2, then B, B1, B2, and last we take C, C1, C2. Here we say that A comma 1, A comma 2, B comma 1, B comma 2, C comma 1, C comma 2. Now we see Venn diagram. हम कोई ना कोई चीज को ग्राफिकली रिप्रेजेंट करते हैं, वैसे ही सेट्स को भी ग्राफिकली रिप्रेजेंट वेन डायग्राम से करते हैं. सो बेसिकली इट इंडिकेट्स द रिलेशनशिप बिटवीन द सेट्स. वेन डायग्राम का नाम इंग्लिश मैथमेटिशियन से पढ़ा है जिसका नाम था जॉन वेन. अब हम देखते हैं वेन डायग्राम को रिप्रेजेंट कैसे करते हैं. सो देयर इज अ वन यूनिवर्सल सेट which contains all the elements of all sets which are represented by rectangle. मतलब हम जो भी elements लेंगे उनको रिप्रेजेंट रेक्टेंगल से करेंगे. एंड यूनिवर्सल सेट स्पेशली चेंज होते रहता है जैसे हम दूसरे एलिमेंट्स कंसीडर करते हैं. नहीं तो कुछ लोग सम सॉल्व करेंगे बट यूनिवर्सल सेट ही गलत लेंगे. Inside the rectangle We represent sets by any geometrical figures like a circles, triangles we do. And inside the circle, we take a points to represent the elements of the set. Now we see one sum for better understanding. Here we see that it is the universal set because universal set is represented by a rectangle. It is an circle which represents the set, and A, E, I, O, U are all the elements which are represented by points in the set V. Now we see the size of set. Let S be a set if there are exactly n distinct elements in S where n is a non-negative integer. We say that S is a finite set and that n is the cardinality of S, and the is cardinality of S denoted by this way. So we take some examples. Let A be the set of odd positive integer less than 10. So basically कितने positive integers है less than 10? 1, 3, 5, 7, 9 means there are 5 positive integers less than 10, odd positive integers, sorry. So we represent the set A this way. The size of set A is equal to 5. Now we see second example. Let S be a set of letters in a English alphabet. So how many alphabet are there? There is a 26 alphabet. So we represent the size of set this way and it's equal to 26. Now we see another example. The null set has a no element. So null set, it is a null set and no elements means it is a 0 because cardinality is 0 because there is a no element. अगर आपको वीडियो अच्छी लगे हो तो लाइक कीजिए, अपने के दोस्तों के साथ शेयर कीजिए और सब्सक्राइब जरूर कीजिए फॉर अपकमिंग कैलकुलस एंड डाटा स्ट्रक्चर सीरीज।